Welcome to the Conference Center and Global Specs Industrial Automation and Robotic Systems online event. While cables and hoses are often an afterthought in robot designs, they are a vital part of machine reliability. Headaches range from tangled and corkscrewed cables to complete breaks that cause downtime, lost revenue, and damaged reputations. Now, before introducing our speaker, we'd like to invite you to submit questions at any point during this presentation by using the Submit Question button at the base of this video console. Also, some of the presentations you will see today include detailed information, so we would encourage you to click the Download PPT button so that you can follow along with your own copy of the PowerPoint slides. Kevin Wright is the Country Sales Manager for the Canadian subsidiary of igus Incorporated. With 11 years experience in the motion control field, Kevin has extensive knowledge of cable management systems for robotic applications. Kevin, welcome to today's event.
Great, thank you. As I said, I'm Kevin Wright with igus Incorporated, leading manufacturer of e-chain cable management systems, chain flex continuous flexing cables, and iGlide self-lubricating polymer bushings and dry linear slides. Today I'm going to talk about a concept for robotic dress known as the less is more approach to robotic cable management. In the presentation today, I'm going to do a brief introduction on industrial robots, influence of cable management systems on the different types of industrial robots, some common cable management mistakes, as well as an introduction to the less is more approach to robotic cable management, and as well as consideration options for cable management on two specific types of robotics, the Cartesian or gantry style, as well as the 6-axis or jointed arm robotic system, as well as then touch on some advancements in plastic cable carrier systems, and then finally touch on some case studies and applications for robotic systems and their cable management. So to start, an introduction on the industrial robot. The term robot was first introduced in Czech science fiction play back in the 1920s. Then in 1942, the term robotics was later used by Isaac Asimov, the well-known American author and professor of biochemistry at Boston University. Now, the definition of a robot is a machine capable of carrying out a complex series of actions automatically. Now, as industrial robots grew and became more popular, in 1970 there were roughly about 200 robots in US manufacturing facilities, mostly in the automotive industry. By 1980, that number grew to roughly 4,000 robots in use in the United States. Then by 2008, there were over 1.3 million industrial robots in manufacturing throughout the world. Now, for robotics, there are 5 main categories of industrial robots. The first being the gantry or linear style, also known as Cartesian, which is characterized by rectangular arms with moving in linear axis in the X, Y, and Z axis. The second being the spherical or polar robot, which has one linear axis, 2 rotational axes around a vertical or shoulder joint. The jointed arm or 6-axis robot is commonly referred to as an articulated robot. It consists of 2 straight components as well as moving in all 6-axis motion. The SCARA, or Selective Compliance Assembly Robot Arm, is a special version of the jointed arm robot. The cylindrical or post style again has 3 degrees of freedom with axis in the Y and Z moving linearly, and the third a rotating arm. Now, as I mentioned previously, we are going to focus mostly on the Cartesian and jointed arm axis, really delving deeper into the robotic cable management systems used in those 2 style of robots, and how the robotic cable management can help and aid in the robotic system. Influence of cable management system. What do all these robots have in common? Typically, the cable management system is left to the last minute. The programming is complete, the floor layout is completed, the end of arm tooling is selected and designed, then it's determined what we need to get power, control, air to that end of arm tool. Then comes the robotic cable management system. Now, why is a robotic cable management or an effective cable management system important? If an unprotected cable fails, it can shut down the most important robot, and the most inexpensive cable fails, it will result in costly downtime of that robotic system. So now we'll touch on a couple of typical or common cable management mistakes. One is using a long restrictive cable management package. This is where the stresses of constricting and extending are transferred onto the cables, and the cables aren't being protected as they're being used and basically basically dealing with all the stress, which the cable management system should. There's also too an uncontrolled movement or path. This is where the movement of the cable management system is uncontrolled and can result in pinch points or catching on tooling or other fixed points in the environment, resulting in cable failure, as well as not controlling the minimum bend radius of the cables, causing overextension or overbending of the cables, which can result in conductor failure and breakage. Or binding cables with protective coverings as duct tape or cable ties, which then results in the cables, instead of moving independently, they move as one, and as well as can basically be bound together, resulting in abrasion and wear between the two cables working on the robotic system. All these techniques and all these common mistakes in cable management can result in corkscrewing and failed cables. And as well as you see from this first picture, the basically not using any cable management system at all, and it's almost basically spaghetti-like. So now the less is more approach to cable management. This is a new thinking that basically minimizes mounting points. It minimizes those potential problems for failure and potential problems that cause downtime. On a 6-axis robot, we'll basically look at it from basically 3 segments. You segment the different axes on the robot as they all have different demands for robotic cable management. Each segment should feature some of the same characteristics as minimal dress pack, so minimal points of problems, minimal attachment to the robot, strain relief with service loops, so if there is cable failure, it can be easily fixed, as well as use of junction boxes to protect the electrical connectors that are joining the cables and basically transferring the power or control throughout the robotic system, as well as this breakdown or segmenting of the robot's cable management by breaking up the axes is crucial for long-lasting cables. And the whole point is you're minimizing or eliminating those potential pitfalls or problems that can lead to cable failure and the end result being downtime or the robotic system not working as it should. So now we briefly touch on this from the different axes in a 6-axis robot. So first off is basically from the 3rd to 6th axis, and we'll get in a little bit further the definition of the different axes. So the 3rd to 6th is seen as one component, using strain relief at the moving and fixed end, protecting the cables and hoses with a multi-axis cable carrier that is modular, as well as segmenting the cables within the system to prevent them from rubbing and basically having jacket abrasion that can lead to conductor failure. The 3rd to 2nd axis, as well, using a multi-axis cable carrier, again using service loops and junction boxes, and again segmenting the cables to prevent cable abrasion. And again, as well as on the 2nd to 1st axis, again using a strain relief on the fixed and moving ends to relieve stresses that the moving stresses on the cables, as well as installation of a rotary cable management system that moves in that the rotary axis of the robot versus as something as a reverse bending cable carrier, as well as using junction boxes as well to help eliminate or aid in relieving stresses off the connectors in the system. So now we're going to change gears a little bit and really take a look at the gantry style robot. Now, characterized by a gantry style robot, it handles high speeds, heavy loads. It works on the 3 linear axis and moving the X, Y, and Z axis, and can contain a very large work envelope. It can be seen in a large material handling system for moving product from one end of a warehouse to the other. It's mechanically rigid, as well as has a high degree of repeatability and accuracy. Typical applications in the industrial world are injection molding robots, retrieving product that's just been molded out of the injection molding machine, high volume material handling systems and palletizing systems, as well as pick and place robots seen in the packaging industry, and again on palletizers and other cartoning machines. So some considerations for a cable management system. One is you don't want the cable management system to limit the speed of the overall system. A Cartesian style robot is characterized by moving fast and high efficiency. Your cable management system needs to keep up with this robot. It needs to manage all types of cable and hoses, whether it be control, power, or fiber optic, and as well protect cables from harsh environments, depending what debris is in the environment, if there's weld spatter or any sort of caustic element to the environment, the cables need to be protected. Does not limit acceleration. Again, this robot needs to move quick and it needs to get there fast. The ability to easily add and remove cables. In today's production, as demands on production change, your robotic system needs to be adaptable and change with production, and you need a cable management system that basically allows this to happen. No media restrictions, as I mentioned, from power. You also need to include fluid, whether it be pneumatic or hydraulic, or air, as air as pneumatic, as well as fiber optic. All types of media need to be able to be conveyed in this robotic system. One of the staples in this type of industry is using a busbar system. A busbar system is a power and control that's distributed via brushes along a fixed copper or aluminum strip. The copper aluminum strips are charged, and then as the system moves, the brushes come in contact with these charge strips, therefore transferring the power into the robotic system. This is versatile in small spaces, as well as can be easy to install. Some of the limitations on a busbar system is it's difficult to add conductor strips. Once the system is in place, it's usually above head, and then adding conductor strips can be quite cumbersome and maintenance involved. Limited power is limited to power and control cables. Obviously, no fluid can be transferred through the busbar system, as well as air or fiber optic can also not be transferred through the system. Susceptible to failure in harsh environments, whether it be a mist, or if there's high humidity in the environment, or debris, or any other sort of caustic media, that can result in brush damage, therefore impeding the transfer of power or control information into the robotic system. And as well as brush bar maintenance is quite difficult. As I mentioned before, it's usually above head, hard to get at, and requires quite a high level of maintenance in those environments. Another option is a plastic cable carrier. Now, a plastic cable carrier is designed with lubrication-free plastic fiber reinforced material blend that is constructed by using two side links, a crossbar, and on top and bottom for construction of an individual link. Then these links are then connected to form a cable management system, and then glides back and forth with the robot as it moves. Now, this is a modular design that the links can be added and subtracted as demands on the system change, as well as using a simple tool as a screwdriver. It's easy to access cables that are installed by simply removing the top or bottom crossbar. Screwdrivers are available from the manufacturer. This design is also, because of using a high fiber reinforced plastic, these plastic cable carriers can withstand high speeds and accelerations, as well as quite heavy loads in quite heavy fill packages as cables, hoses, hydraulics as well. Some limitations on a plastic cable carrier system is that when temperatures get too hot, over 260 degrees Fahrenheit, some of the mechanical properties of the system are affected, as well as if high concentration acids or other caustic chemicals are used that will have an effect on the plastic or can cause some degradation in the material. Now, there have been some advancements in plastic cable carriers that directly add value to a Cartesian or gantry style system, as well as other industries as well. So with the standard design, it uses what's called a pin and bore, the pin being on one link and the bore being on the other. And as they're connected, that pin and bore facilitates the movement. Now in this case, this is a wear point as well as apply some strength. The introduction of a cable carrier that removes the pin and bore and uses a elastomer link to connect the links, as well as control. Now, one of the results of this is that it increased speeds and acceleration of the cable management system, as well as quite quiet and smooth as it moves. So in industries such as injection molding, if you have 300 robots working, or 300 systems, molding systems working together, by reducing that sound or reducing that noise created by your cable management system creates a much more pleasant work environment, as well as increased speeds. You've you've then taken a limitation off the robotic system from the cable management system, and now you can increase cycle times on the injection molding system, therefore increasing efficiency as well as productivity. The second is, again, for Cartesian style or large gantry systems, is sometimes referred to as long travel. Now, in systems where the travel is of, say, 50, 100 feet or much higher, the cable management system needs to then come down and glide upon itself. And as the top run will glide on the lower run, the integration or use of a cable management system with an integrated roller. The roller then glides on top of the lower run. The roller reduces stresses and friction and drag on the entire system. That reduced friction directly results that less drive force is required, less stress on the motor, higher efficiencies, as well as higher speeds are capable, and longer travels. Travels up to roughly just under 3,000 feet, as well as speeds up to over 33 feet per second are possible. Again, by using this advancement, you're then therefore enabling the system, the robotic system, to work more efficiently and more productively. Now we'll jump back into the jointed arm or 6-axis robot. Now, these robots are characterized as 6-axis robots because they have, 6 axes of movement. The first axis, second, third, fourth, fifth, and sixth. This is ideal for restricted areas as well as irregular movements. It articulates and moves in all directions, and as well as characterized by a shoulder and elbow joint, almost human-like construction. Typical applications for a 6-axis robot are in the assembly or automation in robotics fields, machine tool systems where obviously loading and unloading product into a machine tool, handling systems, as we mentioned, as palletizers and large material handling systems, and as well as packaging machines, whether it be a cartoner, filling machine. These are all use 6-axis robots. So some of the considerations from a cable management point of view. In this case, the cable management needs to be on one continuous path, one repetitive or controlled path of movement. This eliminates the risk of catching or sudden pinch points in the system. Eliminating loose or unmanaged cables. Again, you want your cables controlled at all times, and again, this helps basically to eliminate those pinching or catching on tooling that will then result in cable failure. Controlling the minimum bend radius of the cables. Cables are designed and continuous flexing cables are designed with a minimum bending radius that they're capable of moving at. Using a cable management system that does not control this minimum bend radius will then apply stresses on the inner conductors, which over time will result in failure. Also, the ability to quickly add or remove cables. This again is for today's production, being lean and adaptable to the different demands of production. Your robotic system also needs to be able to be adaptable and change and modular, as well as an enclosed system for harsh environments, whether it be on a paint line, welding system. The cables need to be protected from the harsh or caustic debris in the environment. Some of the mainstays or cable management system used is flexible tubing. This corrugated tubing is designed using a strong outer plastic or polymer tubing. It comes in a wide range of styles. Styles are available, and the cables are then basically carried through the tubing, and basically then this controls them in the environment. It has superior tear resistance from its construction and is connected on 2 points on the robot. This is also characterized that it is able to move in all directions and reverse bending. Some limitations for this system are torsion resistance. The system does not like to be twisted and move. So on a 6-axis robot, torsion can be an issue. As well as being fixed in 2 points. Being fixed in 2 points, the flexible tubing can stretch and constrict with the robot movement. As it does that, some of those forces can be transferred on the cables within the system. Therefore, those stresses then can lead to cable failure. as well as tooling interference, because again, there's no spring-loaded or control mechanism on how it moves. It can then catch on tooling or other fixed points in the environment, causing failure of the system. The second option is using an enclosed dress pack. This also incorporates using flexible tubing, but what's different about this, in a plastic housing, there is usually, in the plastic housing, the tubing is regulated or controlled from extension and retraction by a spring-loaded design mechanism. Now this is characterized that the plastic housing is then also usually packed with grease to facilitate quick and lubricated movement. The cables are protected inside the corrugated tubing, and as well as are controlled through the spring-loaded design mechanism. Some limitations on this system is difficult to maintain. If there's any sort of cable problems or cable failure, the entire system needs to be replaced. It's not easy to add or remove cables. Its fixed length is limited to crossover, so it's not easy to add or extend the length of the tubing. Therefore, as demands on the robot change, if programming changes, the system might need to be replaced. Again, so not ideal for programming and robot changes. And as well, it does not prevent cables from extending past that minimum bend radius. There's no limitation on the movement of the corrugated tubing. It can bend quite tight. And as I did mention before, it is not a modular system. The next item that we'll talk about is using a modular polymer robotic cable carrier. This is facilitated by on this sample here of this small model of this system along between the 3rd to 6th axis. It mounts directly to the robot, utilizes a spring-load design that controls the movement of the cable carrier. Cable carrier length can be adjusted quickly, as you see here with this piece here. It is individual links constructed in a chain that can be added easily. The extra links can easily be added to lengthen or removed to basically to subtract length. Stream relief options are possible. If we go back again to our model here, stream relief at the fixed and moving ends, relieving those stresses that are on the cables, as well as there's the defined bending radius, that the cable carrier is not possible moving past that defined bend radius, therefore protecting the cables on the inside that they are not capable of bending past that defined bend radius. Again, some limitations are that we touched on with previously in the gantry portion is that, again, high concentration of acids and other caustic chemicals do not work well with the plastic, as well as circular movements for heavy loads. So if you have a heavy loaded cable carrier system, the cable management system will not be able to support, and we can have some problems. You have to use a different system in those high side-mounted unsupported applications. So an ideal cable management system looking or incorporating those features of the less is more approach to robotic cable management. Now I'll go back to the model here and as well as talk about. So integration of a spring-loaded design. This is very important because it controls the cable carrier as it extends and moves. The cable carrier is held tight, and then as it retracts, the system retracts the cable carrier out of anything that can. So you're eliminating the possibility for catching or pinch points on fixed objects in the work environment. One module, and in this case, this Triflex RS module connects at the top and at the moving end, and is quite limited on the mounting portion to the robot, and covers all 3 axes, upper axis, as well as has a function of a stop limit that prevents the cable carrier from overextending, therefore preventing it from hanging or drooping in the environment. The stream relief is probably one of the most important features of the robotic system, that it relieves those stresses off the cable as it moves. So you're not pulling or pushing the cable in the system. As well as the modularity of it. Again, as your demands and production change, you can add and subtract cable carrier to the cable management system. Again, so all these components go into that less is more approach to robotic cable management, that you're using less chance of failure, less chance of downtime, minimizing those potential pitfalls in robotic system, as well as using a system that is maintenance friendly and has a high degree of of modularity and can change and adapt as the robotic system will change and adapt with production demands. All these elements, again, go into incorporate the less is more approach to robotic cable management system. Now, we'll touch on quickly some applications here. Now, in this first picture here, this is from a car manufacturer for front and rear axle transmissions. Now, in this case, you don't quite see the retraction system on the top of the robot, but again, it's controlling the movement of the cable carrier throughout the system. And again, it utilizes strain relief as well as a service loop near the tooling point. So if there is any cable problems, there's a service loop there for quick maintenance and to get the robot back up and running quickly. Utilizes a modular triflexar robotic cable management system that again can adapt and change as the line changes, and again is quite easy for if there's any sort of debris or broken parts. It's quite easy to fix and is very maintenance friendly. The second picture here is from the packaging industry. Now, this robot is packaging 17 different formats of cartons and filling glass bottles into different cartons for case packing. Now, in this case, you see along the top there is a flex bar system that again is the spring-loaded design that controls the path of movement of the cable carrier, that prevents it from catching on the tooling or any other points in the environment. And again, this is utilized as a triflexar robotic cable management system on a couple portions of this robot. And lastly, we'll look again at another assembly line in the automotive industry, utilizing 6-axis robots for, again, assembling, in this case, windshields and windshields on a car while it's coming through the line. Now again, you don't see the retraction system, but again, this utilizes a Triflex RS system for retracting the cable carrier system and preventing it from basically getting caught on any of the tooling or any other aspects or any other fixed points in the environment. And again, it's quite a controlled system, and as well as, again, ensures that the line is up and running, as well as quite easy maintenance, as well as modular for line changeover and changes within the environment. igus Inc. is, we mentioned before, is the leading manufacturer of energy chain cable carrier systems, Triflexar robotic cable management system, chain flex continuous flex cables, iGlide plastic bushings, and iGball spherical bearings, and Dryland linear slides. It is founded in 1985 in North America, headquartered in East Providence, Rhode Island, with over 160 employees throughout North America, and there's over 60 technical sales engineers in the field available to see our customers. Just under 90,000 square foot warehouse with 8-to-8 customer service. igus Inc. is a wholly owned subsidiary of igus GmbH, which is founded in 1964. Is locations in 27 countries, headquartered in Cologne, Germany. As I mentioned, 27 locations in different countries, as well as partner in another 33 countries with a global reach across the world. Over 1,600 employees throughout the world, and igus Inc. performs 1,500 to 2,400 tests per year in their development of new products and new systems for different industries. igus manufacturing facility operates roughly 300 injection molding machines and produces just under 43,000 linear feet of energy chain cable carrier systems per day. That's roughly 1 million individual parts per day. On igus.com, you'll find a couple of design tools that make it easy to work with our product, as well as make the design process quite easy. We have an e-chain product selector that helps you choose the correct product for your application, an energy chain configurator that helps you with determining correct internal separation inside the cable carrier, as well as quick pin cable connector, which helps you design and pin out for connectorized cables, as well as the picture on the screen here you see of the robotic system. There's also a quick robot system that will also help you design your cable management system for your robot. Thank you again. Thank you for attending. And again, I look forward for any questions and comments that you might have. And here's again some contact information. And again, if you have any questions, please feel free to ask.
Okay, thanks, Kevin. And we do have some questions from the audience. The first one asks, what are the dangers of not housing and protecting cables in a robotic application?
Good question. Well, unprotected cables are susceptible to damage from debris or other contamination in the environment. the risk of catching on tooling or other snag points in the work environment, as well as if you're not using a cable management system at all, this means all moving stresses are then transferred onto the cables, which will cause them to fail over time, as well as just puts too much stress on your cables.
Okay, next question. At what point in robots' design should the cable management system start being considered?
Good question as well. Well, once the program is complete or is known, but can still be adjusted, as well as the end-of-arm tooling needs are determined or even designed, but you can still make adjustments to the programming and the movement of the robot to incorporate a cable management system to ensure that's going to work effectively and efficiently.
Okay, let's take a look at another question. What are the 3 main elements that every robotic cable management system should have?
Well, that's a good question as well. The ability to protect the cables and hoses from hazardous conditions in the environment. As we mentioned before about weld, spatter, paint, and other debris, you need to protect the cables from these hazardous conditions. Ensure a controlled path of movement. Ensure that you know where the cable management system is going to be moving with incorporation of a spring-load design, as well as maintaining a defined bending radius. And most again, importantly as well, is modularity, the ability to add or subtract cables, cable carrier length, or shorten the system as demands change, as well as to make it maintenance friendly.
Okay, we've got time for a few more. Can a plastic cable carrier deliver the same performance in harsh environments as a steel cable carrier?
Yes, it can. Reinforced plastics used in polymer cable carriers are very resistant to debris, hot chips, weld spatter, and can be used in the harshest environments and will never corrode as steel carriers can and will.
Okay, we've got time for one more question. What makes the less is more approach a better solution compared to other cable management options?
Well, the less is more approach encompasses a number of different elements that, by overall using this strategy, ensures a better cable management system. The end result is a smooth, maintenance-free cable management system for that robotic application that, again, minimizes chances of failure or chances of downtime, which is most important.
Okay, Kevin, that's all the time we have for questions today. We'd like to thank you for your time and your expertise.
Well, again, thank you very much, and I appreciate your attention.
Now, before moving on to explore the exhibit hall of this event, please take a moment to click the Take Survey button and let Kevin know how he did today. Your feedback helps us improve the quality of our Global Spec events, making them an even better investment of your time. In between sessions, head to the exhibit hall where you'll find manufacturer product reps, engineers, technical specialists, and other professionals waiting to answer your questions. Now remember, you can see any of today's presentations during our on-demand period, but exhibitor representatives are only here on the day of the live event, so spend time with them while you can. Please experience our latest innovation, the Knowledge Exchange, offering product demonstrations and our hot topic audio briefs. The Knowledge Exchange is also home to our Event Prize Center, so make it a point to visit. Share your thought leadership point of view by speaking at one of our events. You can find the speaker submittal form at our event help desk in the exhibit hall. We'd like to thank you for choosing to spend your day with us, and we'll see you back here in the conference center a little later on.